First thing about redstone is that it only travels 15 blocks. So 1, 2, 3,
Yeah,
4,
I
5,
know that.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And if I
And
do
the
a
next one,
16th one, this one is off.
you gotta do that.
No. What you do to keep it moving is you add a repeater. Oops. And then it starts from 15 again. 1, 2, 3, and 15, right?
Okay, what's the difference between a repeater? Why does a repeater need to be here?
Because it repowers the stuff. You see, if I take this current around, it doesn't carry on. And if I put a repeater here and a repeater here, you can see that that one's on and that one's not on. Even though this torch at the other end of the wire is powering the wire. Right here, it turns off. You see it's not sort of glowing or sparkling or anything like that.
Yeah, I see that.
So, yeah, I think I should put it right here. So it's like pretty obvious that.
So it won't let it go this way because this redstone wiring is connecting to this repeater.
No, that is not why. It is because it's more than 15 long.
Why isn't it powered up right here on this block? Why
Because
is
that is 16 from the torch.
Oh, now I see.
Yeah,
Okay.
so if I
I
put it
get where this is.
here, I can put a repeater here and it's powered.
Yeah, okay. But
So I
see,
can
if
put-
I place redstone right here, or I should get rid of this first. If I place
So-
redstone here, it doesn't get power.
Yeah.
Yeah. Okay.
So
now I
you see
see.
now, if I can put 3 off the side here before it gets unpowered, it's just the total length from the torch, right?
All right. I see.
And then so repeaters,
But here, why did you put a repeater instead of just a redstone torch?
because if you put a redstone torch, the redstone current thing can't carry a current, or it can't carry a value. It will always stay at 1. So if I have a lever at this end now, if I replace this torch with a lever,
Then the
I can
lever
toggle
senses-
it on, and then that will turn on the repeaters and stuff, except the ones on the side that it can't reach. And But if you put a torch in the way, just put a torch there. Put a torch over there somewhere. There you go. So now you see it's that torch can reach the other ones as well. So if I turn this lever off or on, it doesn't matter.
Because
what I
the
do
torch
with
is powering it.
Because the torch is powering it. So
I
now,
see. The lever, because we're using repeaters, we don't need the torches, so we can like set it optimal on off,
Yeah.
as opposed to a torch makes it on permanent. I see. Okay.
yes.
Yesterday I was trying to detonate a massive TNT bomb from like 50 blocks away, and I couldn't do it because I kept using torches. Maybe this is the way to do it.
Yes, this is the way you would do that. So, in the old version without repeaters, what people would do is, because when you stick a current into a block and you put a torch on the other side, just go flip that switch for me, please. It turns the torch off. And then if I put, this is the old repeater, and then the block can be powered by a piece of redstone above it, which turns off the torch. So this is the old repeater. This is what it used to look like. This is how they did it.
That's the
Now,
repeater.
if you're wanting to carry current far away, this is very inefficient because it's slow. What would be the best is if you had pairs of, you see, if I had like, and I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go, like that. And then, so that would go that far, and it would stay the same state. So when the lever is on, that other side is on, and when the lever is off, the other side is off, as you can see. Now if I put a parallel thing here, and then if I put a torch like this,
They both reach the same distance. Actually, they don't.
One of them is a bit shorter, you see? That one is there, this one is here. So and then if I put a torch here, now that torch and right here are the same distance, or I mean state. but this torch is going to power for another 15 blocks. So, and it's just as fast as that one. So this would be more efficient for long distances. But
One on the right, right?
But the equivalent of this, which would be just as fast and would be easier to make, is like this. Because a repeater can push current through a block, you can get an extra block of distance. So if I just take this out, and then I put a repeater and a block, the current on the other side still gets powered. See that?
Mm.
So, but a block that does not get powered through it is glass. Glass, you cannot push current through glass. But you can push it through wool or dirt or I think any other block. Let's just see if glowstone does it, or is glowstone like glass? Yeah, glowstone is like glass. And you can even do it through bedrock, I think. It's kind of useless, but yeah. So you can just actually probably do it through any block, which is pretty darn cool.
Hmm. Leaves.
Not leaves.
Leaves are leaves. They go right.
Just normally we use wool or dirt, and then glass is for not getting through. If you were going to make some sort of compact memory disk or something, you could use glass as a 0 value and wool or dirt or any other block that does conduct as a 1 value.
I see.
Right? And then you could just read it by pushing it along with pistons or something, which would be really cool, like my music machine on the other server. Anyway, continuing, you can use the fact that if there's any current coming into the block that a redstone torch is on, turns it off to make digital logic gates. So this would be, come on, there we go. This would, I'm going to demonstrate an AND gate in its most compact form. Each of these redstone torches on a block could be considered a NOR gate. So if you have 2 knots behind an AND gate, or a NOR gate, it would make an AND gate in digital logic. So this is exactly what that is, and that's what an AND gate looks like. So if you turn on both of those levers, then this one on the other side will turn on as well. But only when both of them are on. So if one of them is off, it is not on. And if both of them are off, it is not on. So hence the word AND, since the first one and the second one have to be on.
It kind of reminds me of the group theory I do, and an OR. So if you make an OR gate, as long as either one.
Yeah, so then a single torch could be considered an OR gate, where I mean a NOR gate, where it's on if either one, or no, it's off if either one is on. So when one of them turns on, it turns off, and if both of them are on, it's off. Right?
Mm-hmm.
So how you would make a OR gate is you would have the output of this one just coming into another block.
I gotta ask you this question: are you in college?
No, I'm in grade 11. Actually.
But I'm guessing you're gonna be a math major when you get into college, ain't you?
No, probably computers. Yeah.
Computers and math, that's what you seem like you're pretty good at.
I'm pretty good at it.
Because all this and OR stuff, I'm like, this is stuff you do in math structures.
Yeah, I just do it for fun. So this would be an OR gate if you just had this old repeater with the inputs going into here. And you could even have another input right here to make it a 3-input OR gate. So if any of these inputs are on, the output is going to be on as well. See that?
Mm-hmm.
And now to make a super duper simple OR gate, what you could do is this. And then put levers like this. Look at that.
Poseidon's pitchfork.
If you turn any of them on, the output is going to be on. But the problem with this one is that it sort of stops. It can give back current. So if this wire is attached to something else as well, and it's just kind of going to two things, and this happens to be one of them, if one of the inputs in this is on, that will be affected. So I'm trying to think of an example. So if you had some current coming in like this from a switch, and you had it go over here, and it did this silly little thing over here. Oh, look at that. And then, oh, look at that, it's opposite. And then you had a few of these in this arrangement. And like this. When you turn this one on, it affects this part as well, even though you may not want it to affect that. And if you want to still use this simple way, you could put repeaters facing from where you want it. So now you see this side here is on, and it affects this, but it can't go backwards and affect the other ones, right?
Mm-hmm.
So if any of these inputs are on, it turns the output on, even this one. But this one is the only one that affects right here. Right? So this would probably be your best configuration for an OR gate, if you wanted to make an OR gate.
Confusing as hell, man. You studied this shit good.
I didn't study it at all.
You just kind of go by logic on what would happen?
Yeah, I use... I start from scratch every time, and I just kind of know the basics, so it works. So now, if you wanted to make an XOR gate, which would be if the inputs are the same, then the output is off. Otherwise, it's on. So if you no, not an X gate. Come on.
What? I'm just putting an X as redstone torches. I'm just fooling around. I've heard of XOR commands.
So here is my design that I made for an XOR gate. So now if we turn either of these switches, then this output right here, this is the output. Anywhere along this wire is the output. If we turn one of them on, the output turns on. But if we turn the other one on, the output turns back off. Applications for this.
I know what XOR is. Isn't it? It'll turn on if and only if you turn only one input on. Only one input gets it to go right.
No. Well, I guess.
Yeah, like an XOR statement is true if and only if you pick the right one. Otherwise,
I guess that would work. I'm just gonna see if I can make a more compact version of this, just for lols, because I sort of had an idea for it.
let me see if this.
Oh yeah. If you went like.
Yeah, I knew it. That's exactly how I thought it was going to do. It only works if you pick one.
Yeah, you could do this. And then you'd have to have one right here. And then... yeah, that would screw up. Pretty bad. So it would be a bit slow, but this would work. No, that would not work. Crap. Okay. We could do this to make it work. And then we can put the switch like here.